run. So this is how we prioritize. If there is a change in this statement, only T2. So this is how T2 is first, then T3. Because if I make a change here, then all three will be run. But if I make a change here, then only T2 will be run. So this is preferred over T1 and T3. So this is prioritization of the test cases on the basis of execution slice. That is on the basis of the number of statements which are executed when there is a modification in the program. All right. So this is how it is highlighted here. That is, suppose there is a change in this statement. So these are all the statements which are highlighted will be executed. Whereas if I change here in case 3, then all T1, T2, T3 will be executed. So on the basis of execution slice, we prioritize T3, T2 and T1. All right. So this is the prioritization of test cases on the basis of the number of statements which fall in the execution slice when the program has been modified. Now, as we have done it in the statement level, we can also do it at the function level or the module level. Okay. So we, instead of like here, we are determining that which program statement is executed under each test case. Okay. So here we, in case of if we do a execution slice under the function or the module, we will simply determine which functions or modules are invoked under each test case. Okay. So therefore we will execute only if the number of functions or if the modules which are invoked by the test case are less, we will prioritize that test case first. So this is how we are basically reducing or prioritizing the test cases on the basis of the execution slice. It can be either statements or it can be either the functions or modules which have been invoked by that test case. Modification in the program is done. Another concept of dynamic slice. Okay. Now what does dynamic slice means? That, okay, here it means the set of statements which fall under a test case and which have an effect on the output. Okay, so this is called the dynamic slice of the program with respect to the output variables. So in case a test case is executed, so the set of statements which are having an effect on the output variable of the program and which are contained in that in that set of statement, that is called the dynamic. Like in the previous case, T3 was not running because employee ID cannot be 0. T1 and T2 will run correctly in the for the program. Now suppose we make some modification in a statement number 10.1. Now this is the statement number 10.1 which says I is equal to 25. So isme ek kara. Now this change is not affecting any of the output variables. Okay, na? I is equal to in 10.5 I say I is equal to 25 की जगह पे मैंने कुछ changes कर दिए. Now it is not effective any of the output variable. So there is no need to rerun any of the test cases for here. Now if I suppose if I change S10 here, S10 में मैंने change किया. S10 में sum is equal to A plus B plus sum है. So here what will happen, suppose we change the formula to sum is equal to A into B plus sum. Now this will affect the variable sum. So therefore there is a need to rerun the test case T3. So that test case which is affecting the change in the output variable, or it is containing the set of statements which are affecting the output variables, so if you see that in case of T1, T2, they are not affecting the they will not be affecting the variable here. So the T3 affects the variable sum and in that case only T3 has to be executed. So the idea behind this dynamic slice is that only those test cases or only those test cases which have statements where there is a change in the output variable, ऐसी सेट ऑफ स्टेटमेंट्स जो टेस्ट केस ऐसी सेट ऑफ स्टेटमेंट्स को एग्जीक्यूट कर रहे हैं जिसमें कि आउटपुट वेरिएबल की स्टेटमेंट में चेंजेस हमने करे हैं. So there is a possibility of the effect on the output variable because we have modified the relevant statements. So only those test cases are run. So that is dynamic slice. So we will only pick up those test cases which will execute those statements where we have done a change in the output variable, or where we have done a change in the statement so that there is a change in the output variable. So that is what is called dynamic slice. So if you will see this program, there is only T3 which is running these statements where there is a change in the sum. So in the statement number 10.1, so we will run only T3. So that is what is the dynamic slice. So we and the third is a relevant slice. So these are actually the slicing is that we cannot run the entire, we cannot rerun the program. रीरन द प्रोग्राम हम नहीं कर सकते सारे टेस्ट केसेस में, तो हम वो टेस्ट केसेस उठाते हैं जो कि स्लाइसेस जो हैं या आइदर इट इज द एग्जीक्यूशन स्लाइस or it is the dynamic slice or it is a relevant slice which have got which are they are prioritized on these basis. If execution slice is the number of statements जिसमें कम होंगी, और डायनेमिक स्लाइस वो होगा जिसमें कि आउटपुट में अगर कोई चेंज हो रहा है वो स्टेटमेंट्स को वो कवर कर रहा है. देयर इज अ पॉसिबिलिटी ऑफ द चेंज इन द आउटपुट वेरिएबल. एंड द थर्ड कैटेगरी ऑफ प्रायोरिटाइजेशन बेस्ड ऑन स्लाइसिंग इज कॉल्ड रेलेवेंट स्लाइसिंग. नाउ here these are set of statements that was executed in a test and they do not affect the output but have the potential to affect the output produced by a test case. So that is what we call as a relevant slice. So they have not affected but they have a potential. Okay, so what it will contain is it will contain the dynamic slice and it will also include those statements which, if corrected, may modify the variables at which the program failure has manifested. Okay, now again going back to this program, if we see statements S3 and S6, if we see statements S3 and S6, so S3 and S6, so they have a potential to affect the output. They have a potential to affect, if anything goes wrong here, they have a potential to, if A is B is equivalent to 0 and A is equivalent to 0. So here they have a potential to affect this output. So they will form a part of the relevant slice then. They will form a part of the, they have a potential to affect the output if modified. So, okay. So we will now therefore, execute, if you want to prioritize on the basis of relevant slice, then we will run only those test cases where who have these relevant slices or who have the output variables which are have the potential to this thing. So have the potential to affect the output. So dynamic slice here which are actually, so basically when I talk about relevant slice, it will contain dynamic slice also, and it will contain all those statements which have the potential to affect the variable. So we will have, like here if I am talking, we will have S3, S6, all those test cases which cover S3, S6, and जो पिछला का जो है T3 है, T3 का जो statement है. So any test case which will cover this statement where the sum has changed, plus the statements S3 and S6 which have the potential to affect the variable sum because they include the variable A and B. So that will form a part of the relevant slice. So again, on the basis of relevant slices, we can prioritize the test cases. So basically, all these techniques are for prioritizing the test suite for saving time and effort in regression testing, because we cannot execute the entire program, we cannot rerun it. So we pick up only those statements which are which have either been have the least number of test cases or least number of test statements. If at all we want to rerun the previous test cases, then those which are having the least number of statements, and those which have the potential, which are affecting the output variables, and those which are having the potential to affect the output variables. So we'll pick up only those test cases which go through these slices. So that reduces the regression test suite, because obviously we do not want to rerun the entire, we do not want to rerun all the test cases of the previous of the program if we have changed the new version. ये नहीं कि उसमें सारे हैं तो हम सारों को ही रन करने लग जाए, हम उनको प्रायोरिटाइज कर लेंगे, और हम अगर टाइम है तो सारे रन कर लेंगे, और अगर टाइम नहीं है तो जो हाईएस्ट प्रायोरिटी है उसको रन करेंगे, फिर सेकंड को रन करेंगे, एंड the running the highest priority will make sure that we have actually hit the actual problem, that is we have taken care of the modifications. So main thing is that modifications should not affect the whatever modifications have been done, they should not affect the already running program. So that is what is the concept of prioritization based on the program slices. It could be either execution slice, it could be either dynamic slice, and it could be a relevant slice, which is a combination of dynamic slice and the statements which have the outputs, or the statements which have the potential to affect the output variable. So that is what is the prioritization based on the basis of the program slices. So broadly, what we have covered is we have covered prioritization techniques on the basis of code coverage, that is statement coverage, all and additional, then branch covering, all and additional, then we have fault exposure potential, then we have risk-based prioritization, and finally we have talked about the prioritization based on the relevant slices, the program portions of programs which have the maximum, or which are the most probability or should be checked, after the modification they have been actually, they must be checked. So we pick up the slices of the programs which are most probable to get affected by the modifications. So we could have an execution slice, dynamic slice, or relevant slice. So these are and we have also studied about the prioritization based on the requirements also. If you remember, that is when we talked about regression testing, that is based on the business criticality. We prioritize test cases and we run those test cases which are running the highest priority requirement, followed by the lesser priority, so on and so forth. So the idea behind prioritization of test cases, whether it is in regression testing or whether it is in general for system testing, is to reduce the number of test cases, because in normally because of time crunch, it is not possible to execute the entire test suite. So we must have a way to execute only the more important ones. More important in the sense that they will cover all the faults, and they will cover the most of the faults of the program, or the most of the errors of the program in case of modification of the program is done when we do regression testing. So that is what is about prioritization. This is all the techniques for prioritization of test cases. Now there is another topic, so that completes the topic on prioritization of test cases. I want to start combinatorial design techniques also today. So I'll put up my slides for that. We will talk about the next topic, which is combinatorial testing. So this is slightly lengthier one. So the next topic is combinatorial designs. Now, yes, is this presentation visible to all of you? Yes?
Yes, ma'am.
All right. So just quickly we'll read through it. What it says is that one interesting phenomena is observed by developers. And what it is observed is that some of the programs which have been running very nicely and correctly on some platforms suddenly develop errors when you shift them into a different environment. ठीक है, try to understand this कि आप अब विंडोज पे एक एप्लीकेशन को चला रहे हो, अच्छे से चल रहा है, लेकिन आपने उसका अगर विंडोज का वर्जन ही चेंज करा या कुछ और एनवायरमेंटल कॉन्फ़िगरेशन को चेंज करा, देन द प्रोग्राम stops working or it fails. So, for example, suppose there's an application which has been installed with the operating system, okay, and a database management than used previously. So previously, suppose it was using, it was running on an operating system and using a DBMS package or software, and you suddenly change the OS and suddenly change the DBMS for some newly added customers. So what happens is it is observed that it will not, it stops working. It stops working for newly added customers which have a different OS and a different database management system. And so they have account records with a combination of values that have not occurred before. So there could be different combinations, you know, the trigger failures that have escaped previous testing and extensive use. You know. So what is called, these such type of failures are known as interaction failures. You know. So why they're called interaction failures? Because they are exposed only when two or more input values interact to cause the program to reach an incorrect result. So program अच्छे से चल रहा है, suddenly आपने कुछ environment change करा, कुछ new OS करा, new DBMS करा because of a new requirement, and it stops working because of the interaction of two or more input variables. The failure occurs. So we call this type of failure as interaction failures because this has occurred because of interaction between two or more input values and has caused the program to reach incorrect values. Okay, so this is, now we are going to study in the combinatorial testing. As the name says, combinatorial. Combinatorial means we will study the various combinations of inputs which could lead to errors and how we are going to detect the combinations of inputs. So we are going to study in combinatorial testing the possibility of faults in a program that arise due to interaction among values of different input variables. So OS है, OS could be Windows का version, it could be Mac OS, it could be Linux, or it could be anything. So उसकी अगर values हमने OS की change करी, variable is OS here suppose. So if I change the values of the OS, I use different OS, so there could be a possibility that my program would stop running or would bring failures or would cause errors. So that is what we are going to study in combinatorial testing. We are going to study the reasons and the way to generate test cases or test configuration based on the interaction between the different input variables. Is that clear? What is combinatorial testing? That is the faults which are caused because of interaction amongst the input variables. Is that clear? अभी तक हमने interactions of input variables नहीं देखा. If you see everything, we have not, what all techniques we have studied till here, we have not gone into the into this particular field, you know, interaction of input variables. Input variables है, उसकी values हमने लिए हैं और हमने उसके बाद testing की techniques देखी हैं. But the interaction of input variables, this technique is known as combinatorial testing. That is the interaction between the variables. So interaction failures is one of the primary reasons why software testing is difficult. तो सॉफ्टवेयर टेस्टिंग अगर एक ही वेरिएबल है, एक ही वैल्यूज है, उसकी कंटिन्यूस वैल्यूड है, तो देयर इज नो प्रॉब्लम. लेकिन इश्यूज जब आते हैं कि आपके पास नंबर ऑफ इनपुट वेरिएबल्स हैं, उनकी डिफरेंट वैल्यूज हैं और उनकी इंटरेस्ट स्टडी करनी है और टेस्ट केसेस जनरेट करने हैं टू फाइंड आउट द एरर्स. सो दैट इज अ टफ टास्क and therefore this is one of the primary reasons why software testing becomes difficult. So if failures only dependent on one variable, अगर एक ही वेरिएबल वैल्यू पे डिपेंड करते हैं तो हम एक वैल्यू टेस्ट करते जाते और हम जैसे इक्विवेलेंस क्लासेस बना लेते हैं अगर इन केस ऑफ द one variable with different values, and we could have a representative range or equivalence classes and make test cases, and everything would have been easy. So if our application had inputs with v values each, so we could just at the maximum require a total of v test, one value from each input per test. Now, real world is not all that simple. We have interactions amongst environmental factors of the working environment of the software, and as such in the software also input variables which might interact with one another. So that gives rise to this field of combinatorial testing. So it is a relatively new form of software testing, and it is based on simple principles such as interaction rule, pairwise testing, T-wave testing, interaction testing. Okay, so these are some of the principles on which this is based. Now, combinatorial testing is again a technique which can drastically reduce testing time and cost. How? By reducing the number of test cases. So what has been our effort in prioritization of test cases also, and in case of studying the regression test problem also, we were always concerned about reducing the number of test cases. If you see that, in fact, throughout this entire course of software testing, right from beginning with the black box testing and white box testing and data flow testing, and now we studied prioritization of testing and regression testing, our focus has been to reduce the number of test cases, because with time, or we see that the number of test cases increases, and we want to reduce the testing time, and that is possible only if we can reduce the number of test cases. So if you see that throughout the various techniques or various types of testing technologies which we have studied, our basic focus or aim was to reduce the number of test cases so as to reduce testing time and obviously cost. Because time कम होगा तो आप you will employ less number of testers, and therefore you will save cost and also. So okay, so combinatorial testing is a very powerful technique which helps us in reducing testing time by reducing the number of test cases. Because that sometimes, as we were just seeing, that reliable softwares fail when certain unusual combination of inputs are entered. So they might fail in the face of certain unusual combination of inputs. So how can we avoid it? We can avoid it if all inputs have been tested previously. So again, it's a tedious task if the number of inputs is very high. So, and this is not possible in modern softwares where we require hundreds of inputs. So we cannot do an exhaustive testing, you know, कि आप हर एक inputs के साथ आप cases कर रहे हो. It will take many years to test one software itself. So this kind of exhaustive testing is no longer a feasible solution in many situations. In case of modern softwares where the number of inputs goes into the range of hundreds and thousands. So now it has been observed by researchers and by experience that majority of bugs which occur are due to the interaction of few inputs only. चाहे आपके पास 100 inputs हैं, चाहे 1000 inputs हैं, लेकिन कुछ ही inputs जो कि critical हैं, उन्हीं के interaction से है bugs आते हैं. That is a proven research. Okay, so practical empirical means which has been proven by experiments. Experimental research has proven that most of the bugs are occurring because of interaction of only a few inputs. ये नहीं कि 100 है तो 100 के inputs के interaction से आएगा. Bugs लाने वाले कुछ ही inputs होंगे. And what has been observed is combinatorial testing allows us to select 2 to 3 parameters at a time, like the environmental in which it is working, OS and platforms, or it could be simple inputs to the program, and test the combination of both the configuration and inputs in a way that majority of faults will come to light with minimum number of tests. This is important. So combinatorial testing drastically reduces the test cases. The techniques of combinatorial testing will drastically reduce the number of test cases by configuration, by selecting only 2 or 3 parameters. 2 or 3 parameters, not hundreds and thousands. And 2 or 3 parameters which could be configurations or inputs. And it will test the combinations in such a way that majority of faults will get resolved or detected by running only few test cases with the minimum number of test cases. So that is the strength of combinatorial. It is a very powerful technique for testing interaction between failures due to interaction between inputs. In the work of the program. Is that all right? Yes. Are you with me, all of you? Yes.
Yes, ma'am.
Yes, ma'am.
All right. So let us talk about pairwise testing now. Now, experimental data shows that about 95% of the fault occurs due to interaction of only 2 parameters. अगर 100 भी है ना तो 100 नहीं affect करेंगे. Then 60 to 95% of the faults are occurring due to interaction of 2 parameters also. कि 2 ही पैरामीटर्स इतने क्रिटिकल हैं कि उनकी से 95% फॉल्ट्स उसी के कारण हो रही है सॉफ्टवेयर में. So if we test all the two-way combinations, we will have a high percentage of errors can be detected. Now, testing two-way combinations is known as pair-based testing. So testing which involves testing of pairs of variables is called pair-based testing. That is what is pair-based testing. Now, sometimes pair-based testing 95%, but at times pair-based testing is not sufficient depending on the application of this thing. Now, like life critical softwares, which are attached to the medical devices. So we would not say that we just would rely on pair-based testing to test for such critical softwares which are used in medical devices for patients. So in such critical cases, pair-based testing ke saath saath higher number of interactions are also considered to make sure that the software is running error-free or failure-free. Because such software where the human life or is concerned, we cannot just, it is sufficient, but we want to make sure that no more errors creep in because of interaction of more number of input variables. So in that case, higher interactions between variable 4-way is also considered. So now what does experimental research shows? It shows that consideration of maximum of 6 factors, 6-way interaction. So 6-way interaction, maximum 6-way interaction is enough to identify 100% faults. 6 से ज़्यादा नहीं. और कुछ केसेस में 4-way interactions. तो 2 है, 2 तो होती है pairwise interaction, और अगर आपको 100% faults करनी है तो 6-way interaction is sufficient, or 4-way interaction is always sufficient. Now for non-critical software, 3-way interaction is also sufficient. So for critical softwares where human life is concerned or more stakes are there, 6-way interactions of input variables are considered for testing, or 4-way interactions are done. And for non-critical software, 2-way and 3-way interactions are also sufficient. So the number of interactions which are taken into account is called the strength of the test. Okay, that is the definition of strength of the test. That is number of interactions which is between the variables. So what are we going to learn in this combinatorial testing is, now we will see what are test configurations. Okay, na? So till now we have just been introduced to the test set. Test set kya hai? It's a set of test cases, and test cases are the inputs and the expected outputs. All right. Now we will see what is test configuration. So this is a new term which I am introducing, test configuration. क्योंकि अब हम external environment को भी हम take care करेंगे. So now we'll see what is test configuration and how is it different from a test set, and what is the combinatorial design and why we use combinatorial design to achieve a powerful technique for testing. Now we will see these procedures for making combinatorial design, Latin squares, mutually orthogonal Latin squares. And we'll see how we generate test configurations from mutually orthogonal Latin squares, orthogonal errors. So these are all procedures for doing a combinatorial testing, covering errors, mixed level covering errors, and how to generate them. So here basically 1, 2, 3, 4, these are the procedures for combinatorial testing. All right, now we have seen what is combinatorial testing and what is the importance of combinatorial testing. Now these are the procedures for doing the combinatorial testing. So we'll study these procedures or these ways of doing combinatorial testing or generating the test cases or test configuration using these techniques. So let us see now what is a test configuration and what is a test set. First of all, so we've just seen that software applications are working in a different environments. You could have different operating systems, network connections, hardware platforms. So her environment, this is called the environment of the software. So there could be number of factors which could determine the environment of a application, like operating system, network connection, hardware platform, etc. So basically, how do you define the environment of for software? It is a combination of hardware and software both. So each environment will have a given set of values for each factor, and that is known as a test configuration. So here we have when we call it a test configuration, which is actually the set of values for each factors. And what are factors? Factors could be operating system, network connection, this thing. और हर की एक value होगी, जैसे अभी बताया, operating system can be Mac OS, operating system can be Windows, hardware platform can be processor, what processor you are using. So the values of each factor for that particular application at that state of time, that gives you the environment for that application. And this set of values for a factors, for each factor, they will form a test configuration. So a test configuration will have, basically, suppose I'm considering these factors. So our test configuration would be one particular value of this, this, and this. That set will become a test configuration. Now, suppose for different set of values for these factors, that would be a separate test configuration. So that is how we define a test configuration. So there is an example of this. Suppose there is Windows XP dial-up connection and a PC with 512 MB of main memory. So this is one possible configuration. This is one possible configuration of my environment. Now, different versions of operating system printer drivers can be combined to create several test configurations for a printer. So basically, you have factors. The different values which these factors will take will form different test configurations. All right. So if we want to ensure a high reliability, we must make sure that the application is tested under as many test configurations. Okay. So now if you see that number of test configurations can be exorbitantly large, अब कुछ भी हो सकता है, आपके पास कुछ भी कॉम्बिनेशंस हो सकते हैं. आपके ऑपरेटिंग सिस्टम कुछ वैल्यूज लेगा, आपका प्रिंटर ड्राइवर्स कुछ वैल्यूज लेगा. तो अगर आप कॉम्बिनेशंस बनाने लगे तो टेस्ट कॉन्फ़िगरेशंस जो हैं आपकी एक एप्लीकेशन के लिए कैन बी exorbitantly large, So it's not possible to test all the test cases which are corresponding to different test configurations. It's impossible, because you have some factors. You have suppose 3 factors और हर एक की 2-2 वैल्यूज हैं, तो आप इमेजिन करो कि कितने सारी टेस्ट कॉन्फ़िगरेशंस बन सकती है. So a test configuration is basically a combination of factors corresponding to hardware and software within which the application is to operate, and a test set is a collection of test cases. ठीक है ना. तो ये डिफरेंस है टेस्ट कॉन्फ़िगरेशन का और टेस्ट सेट का. एंड ईच टेस्ट सेट consists of test cases. And what is a test case? A test case is basically input values and expected output. On the other hand, a test configuration is a combination of factors corresponding to hardware and software both. Now we have brought the environment also into the picture. So combinatorial testing, with combinatorial testing, we have also included the environment also into the picture of testing. So we shall now learn the techniques for deriving test configuration as well as test sets. Yes, is that clear now? Yes.
Yes, ma'am.
Yes, sir.
All right. Now let us see the motivation for combinatorial testing. So while testing a program with one or more input variables, so we'll require at least one value for each variable. That is, we know that अगर हमने किसी test case को run करना है और variable लेना है, तो we at least require one value for that variable for that test case. So suppose that there is a program to find the greatest common divisor of two integers x and y. Now it requires minimum two values, one corresponding to x and other to y. Now, if for equivalence partitioning, do with this part also. Now, if it is a good technique, equivalence partitioning, but it has got some shortcomings. Now, it raises the possibility of large number of subdomains in the partition. And again, there is no guidelines on how to select inputs from the various domains. If you remember, in equivalence partitioning, we just make partitions and we randomly pick up test cases or input values from those partitions. There is no guideline on how to select inputs from the subdomains of the partition. So the number of subdomains in a partition of the input domain will increase in direct proportion to the number and type of the input variables. So if you are doing a single partitioning, basically अगर आपके inputs बहुत सारे हैं तो हो सकता है कि आपके number of partitions बहुत सारे हो जाएंगे. In case of multi-dimensional partitioning में क्या होता है कि अगर आपका input domain है और उसमें आप subdomains बना रहे हो तो that will also increase if the number of inputs increases. So, and we know what we do in equivalence partitioning. Once a partition is just determined, we will just randomly pick up a value from each of the subdomain in case of multi-dimensional partitioning, or in case of a single partitioning, we will just pick up a value from the single partition. Now, such a selection procedure. Now, okay. So this is what it's doing is that we are following an equivalence partitioning. Now, into account the specific interaction amongst the values of different variables. Okay, हमने क्या हमने partitions करे और हमने variables को values को randomly pick up कर लिया. हमने उनके interactions नहीं read करी हैं. We have not read or we have not studied how two input variables are interacting with one another. So that is one shortcoming of equivalence partition. Even though it is considering number of variables at times by making the partitions and picking up values randomly from those partitions, but the interaction between variables or factors has not been taken into account. That is what is missing in equivalence partitioning. It does take into account number of factors or number of variables and different values, but it lacks the concept of interaction amongst those variables. So again, boundary value analysis, we will select test cases which have values at the boundaries, and other interactions in the input domain might remain untested. Now, what we will learn in combinatorial testing is we will learn the techniques for generating test configuration or test cases. So that are small even when the set of possible configurations or input domain is large and complex. So for number of complex configurations and inputs, जो हमारे generated test configuration या test sets होंगे, they will be very, very less. So, okay. So that is what we are going to do in combinatorial testing. Now let us see how we model the input and configuration spaces. So let us suppose there is a program P and the input space or input domain consists of k tuples of values that could be input to P during execution. Now configuration, तो ये input space हो गया. दो चीजें हैं इसमें, एक input space है और configuration space. Remember, input space is the inputs which we are giving to the program, and configuration space is the environmental settings. So there are two spaces. One is the input space, which is consisting of k tuples of values, and another is a configuration space, which is the possible settings of the environment, variables under which P is used. Now let us suppose there is a program which takes two integers, x is greater than 0 and y is greater than 0 as inputs. So input space of P is a set of all pairs of positive non-zero integers. Now suppose that this program is to be executed under Windows and the Mac OS operating system through Netscape or Safari browser, and it must be able to print to a local or network printer. So this becomes the configuration space. It could work under Windows, it could work under, so operating system can take two values, you could have a Windows or you could have a Mac OS operating system, you could have these two types of browsers, and you could have these two types of printers. So configuration space consists of this triple here: YZ, operating system, browser, and a printer. So this is the configuration space, and this could vary. Now, so let us suppose I was just saying that we have got a program which is taking n inputs and corresponding to variables x1, x2. Now these variables, they are known as factors. So we call them as factors, and we also call the inputs as values. So suppose that we have a factor which may be a set from a total of, suppose I is greater than 1 to n values. Now each value which is assignable to a factor is known as a level. तो जो भी हम factors मतलब हमारे variables हो गए, और जो वो value ले सकती है वो उसको हम levels बोलते हैं. मतलब in simple terms, this is what it means. That suppose I have got A, B, C, D, X, Y, Z variables. So these are my factors, and what all values they can take, they are the levels. So okay, and the set of values, one for each vector, is known as factor combination. ठीक है, जो भी कोई वो फैक्टर है जो वेरिएबल है उसकी जो वैल्यूज हो सकती हैं, जो सेट ऑफ वैल्यूज हैं, दैट इज कॉल्ड फैक्टर कॉम्बिनेशन. सो सिंपल, in simple terms, what are your variables? Now we'll call them as factors, and what values those variables can take or those factors can take, we call them as levels. So suppose that a program has two input variables, x and y. Suppose that during the execution, x and y can take, this is the factor combination for x, and this is the factor combination for y. A, B, C, D, E, F. So we have two factors and three levels for each factor. Is this clear? Yes. इतना clear है factor combinations? Yes. Yes, बोलो.
मैम एक और क्लास थी, इसके बाद प्लीज अटेंडेंस ले लीजिए, और ये नेक्स्ट क्लास में कंटिन्यू कर देंगे ये टॉपिक.
अच्छा, इसको एक मिनट खत्म कर लेते हैं फैक्टर कॉम्बिनेशन को सिर्फ.
Yes, ma'am.
Let us just complete the factor combination. So we have two factors and three levels. Is it clear till here? कि variables factors बन गए और variables के जो values हैं वो levels हो गए. Yes. Is this clear?
Yes, ma'am.
So now we have how many combinations? 3 raised to power 2, 9 factor combinations. We have 9 factor combinations. So what I want to see is that this is okay for two factors and